In this video, we're going to be talking about graphs for numerical data, specifically stem and leaf displays. Let's talk a little about some distributions in center. So center. Center is where the middle of the data falls. There are three measures of central tendency: mean, or the average, median, and mode. Now the mean and or the median typically are what are reported rather than the mode. So here we can see in each of these examples, A, B, and C, the measure of central tendency, so that average of each of those distributions. Now something else that we talk a lot about is spread. Now the spread is referring to how spread out is the data. It refers to the variability in the data. So here we can see that our data set for F is pretty spread out. It's pretty wide and diverse, whereas E is a little bit less varied, and D is very tight, hardly any variation there. Now measures of spread are range, standard deviation, and IQR. Now range is our maximum value minus our minimum value. We'll talk more about standard deviation and IQR later in another video. Now, the shape of a graph refers to the overall shape of the distribution. We have symmetrical, uniform, skewed, or bimodal. So what do each of these shapes mean? If we have a hill on the right, what does that mean? If there's a hill on the left, what does that mean? What if there's a middle hill? What does that mean? When we have a hill on either the left or the right side, those are skewed distributions. So if we have a hill that's on the right-hand side, this is what we call left skewed, because the tail goes to the left. If we have a hill on the left, we see that our tail stretches out to the right, and we call this right skewed. And when we have a hill in the middle, we call this symmetrical. Notice that for symmetrical, it almost is like if we were to fold it in half, the two halves would almost lie on top of each other. Let's talk a little bit more about symmetrical. So symmetrical refers to data in which both sides are more or less the same when the graph is folded vertically down the middle. Now a bell-shaped distribution is a special type that has a center mound with two sloping tails, like we see here. So an example of a symmetrical would be if you were to collect the data by rolling two dice and recording the sum of the two dice, and you repeat that 5 times. Plot your sums on a dot plot. What shape does this distribution have? If you've got a couple dice, it's worth trying this and seeing what you come up with. Does it look symmetrical? Does it look like that bell-shaped curve that you just saw? Let's talk about uniform distributions. So that doesn't mean I'm going to hand you a uniform. It refers to data in which every class has equal or approximately equal frequency. Notice here that it's almost like each thing is about the same. So an example where we would see a uniform distribution, we would collect data by rolling a single dice and recording the number rolled, and we'd repeat that 5 times. Then we would plot our numbers on a dot plot. What shape does this distribution have? It should be pretty uniform. Let's talk a little bit more about those skewed distributions that we saw earlier. So skewed is going to refer to data in which one side, the tail, is longer than on the other side. So an example where we might see this would be, for example, if we were to collect data finding the age of 5 coins in circulation, right? So current year minus the year of the coin, and then record that. Then plot the ages on a dot plot. What shape does this distribution have? And it should come out with a skewed. Now the direction of skewedness is on the side of the longer tail, right? So the directions are positively, which is right skewed, meaning the tail goes off to the right, or negatively, or left skewed, and that's where the tail goes off to the left. Such as in these two examples that we see here. Can you name a variable with a distribution that is negatively skewed? I mean, hopefully an example would be the distribution of grades on the first statistics test, right? Where we might have some really, really high grades, lots of high grades, and very, very, very few low grades. That would definitely be a good thing. Let's talk a little bit about bimodal or multimodal. This refers to the number of peaks in the shape of the distribution. So a unimodal has one peak, such as this. A bimodal would have two peaks, such as this example. And a multimodal would have more than two peaks, such as what we see here. Now, bimodal distributions can occur when the data set consists of observations from two different kinds of individuals or objects. For example, consider a large data set consisting of driving times for automobiles traveling between San Luis Obispo, California, and Monterey, California. Now the histogram would show two peaks, one for the cars that took the inland route, which is roughly 2.5 hours, and another for those cars traveling up the coast highway, which goes between 3.5 and 4 hours. Let's talk a bit about unusual occurrences. So here we have a data set. And if you look, you'll see that there are two values that are way out there. We refer to these as an outlier. It's a value that lies away from the rest of the data. Notice that we have gaps. And we can also have clusters. And so those are three different unusual occurrences that we have. Let's talk a little bit about stem and leaf displays. When do we use them? We use them when we have univariate numerical data. So we use for small to moderate sized data sets. It doesn't work very well for large data sets. Well, how do we construct it? Well, we're going to select one or more of the leading digits for the stem. So each number is split into two parts. The stem consists of the first digit, or digits, and the leaf consists of the final digit, or digits. Now, we're going to then list the possible stem values in a vertical column. You want to be sure to list every stem from the smallest to the largest value. Then you're going to record the leaf for each observation beside each corresponding stem value. You're going to indicate the units for stems and leaves in a key or a legend. So for example, here we have our stem 0, 1, 2, 3, 4, 5, and all these numbers over here are our leaves. So if I have 0, 6, that's going to be recorded as the number 6. We can tell because the key tells us that 2/5 means 25. So here, this 9 that's being pointed out right here is in the 3 row, so we would have 39 as our number. Now to describe, you're going to comment on the center, the spread, and the shape of the distribution, and if there are any unusual features. So if it asks you to describe a stem and a leaf display, again, you need to comment on the center, the spread, and the shape of the distribution, and if there are any unusual features. Notice that if we take our stem and our leaf plot and we turn it on its side, it's very similar to a histogram. Okay, so we can use that to help us. So let's consider this. The following data are price per ounce for various brands of different brands of dandruff shampoo at a local grocery store. So we've got 32 cents, 21 cents, 29 cents, 54 cents, 17 cents, 28 cents, 36 cents, and 23 cents. And it wants us to create a stem and a leaf display with this data. Well, what would be an appropriate stem? What do you think? Would you use 0? Would you use 1, 2, 3, 4, 5? Would you use 10, 20, 30, 40, 50? You should use 1, 2, 3, 4, 5 and list the stems vertically. Now for the observation of 32 cents, we'd write the 2 behind the 3 stem. So our 1, 2, 3, 4, 5 are actually representing 10 cents, 20 cents, 30 cents, 40 cents, 50 cents. So notice that there we'll place our 2. Then you continue recording each leaf with the corresponding stem. So we'd have 21, 29, 54, 17. We put our numbers in. So now we simply need to describe this distribution. So we're going to need to find our median. Sometimes we find our mean. In this case, we're going to want to find our median, and we'll talk about why. Now the median, which is the middle price per ounce for dandruff shampoo, is 0.285 with a range of 37 cents. The distribution is positively skewed with an outlier at 54 cents. Because there is an outlier, that is why we use the median instead of the mean, because outliers throw off our mean value and make it so that it is not representative of the population. So here we have the Census Bureau's project. The median age in 2030 for the 50 states and Washington, D.C., a stem and a leaf display is shown below. Notice that you really can't see the distinctive shape for this distribution due to the long list of leaves. Well, we can split the stem in order to better see the shape of the distribution. So we would use an L for the lower leaf values from 0 to 4, and H for higher leaf values between 5 and 9. Notice that now you can see the shape of this distribution. Comparative stem and leaf displays are important. So the following is an example. So we have the following data on the percentage of primary school age children who are enrolled in school for 19 countries in Northern Africa and for 23 countries in Central Africa. And here's our data display. So we're going to create a comparative stem and leaf display. So to begin, we need to decide what is an appropriate stem. So we're going to do something called truncating. So we're going to truncate the leaves to the unit place. So 4.6 is going to become a 4. It's kind of like rounding. in a different kind of a way. So here we can see that down the middle we have our stems, and we have our leaves on the left for Central Africa and on the right for Northern Africa. Notice that it tells us in the legend that the stem is the tens place and the leaf is the ones place. The median percentage of primary school age children enrolled in school is larger for countries in Northern Africa than in Central Africa, but the ranges are the same. The distribution for countries in Northern Africa is strongly negatively skewed, but the distribution for countries in Central Africa is approximately symmetrical. And so it's possible to still talk about the displays when we're using a comparative stem and leaf display. And that's so important to be able to relate them to each other and talk about those pieces.